It's really a pleasure to be here, and I've really been enjoying the conference. I've learned a great deal about a lot of things that I've been interested in, didn't know all that much about, and so it's been really a lot of fun. What I want to talk about today, let's see if we can get this thing to work, is our aspects of Neanderthal energetics. I've been fascinated by Neanderthals for a long time because I think they're my closest relatives. And at any rate, they're intriguing for a number of reasons, and you've heard a lot about it already yesterday, and we'll continue this theme. They seem to have eaten a lot of meat. They're often classified as top predators. The faunal remains certainly point in that direction. There's plenty of animal bones, and often they're the larger or largest animals on the landscape. And you heard yesterday also about the problems we have with fire. They certainly had fire, but it's very on again and off again. You find sites with evidence of fire, other sites with no trace of fire, and even in sites with fire, not every level shows it. And this is also one of these really intriguing questions. So if they're top predators and did not regularly cook, in other words, you don't have evidence of fire that in every occupation, every day of their lives cooking, then eating raw meat is a very costly enterprise. This was talked about yesterday in a number of contexts. There's a lot of chewing time, and to reduce that, there's a lot of processing time that would be involved in chopping it up into small enough pieces to accomplish what chewing does. And then there's this lovely term, diet-induced thermogenesis, sort of like the modern Atkins diet, that it costs a lot of calories to assimilate and metabolize protein. Cooking obviously has a lot of benefits. I've listed them here. We've already talked about these. Basically, cooking does a lot of the digestion before you put the meat in your mouth. It reduces the proteins into amino acids, peptide chains and amino acids. It reduces the heat production, the diet-induced thermogenesis, so it's much more efficient to metabolize it. It adds flavor with the Maillard reaction, the browning reaction that you get, which actually can produce as many as 1,000 different compounds in the meat as a result of cooking it, roasting it, and so forth. It kills pathogens, so there are a lot of obvious benefits. Eating the meat raw, one aspect that nobody has talked about, in fact, I've seen nobody in the archaeological aspects of it talk about, the meat science literature is unanimous in arguing that raw meat is tasteless, that it has an aroma or smell of blood and has no taste. And while Eskimos are famous for eating raw meat, they don't just stick raw meat in their mouth. They're very particular about just how they eat it frozen, but it's not simply a chunk that they take out of the freezer and break their teeth on. They're very particular on the crystalline texture of the meat, and if it thaws too much and gets flaccid, they boil it. They don't like it. So they have very definite cuisine, and something we tend not to think about with the Arctic. We sort of think that they're just living on the edge and stick anything in their mouth that's available. And they have very definite ideas about what is good and what is bad and how to prepare it properly. At any rate, it's already been discussed that raw foodists, the women don't get enough calories, and many become infertile. But we have the data that we have for raw foodists tend to be diets that involve a lot of plant foods. We have, to my knowledge, no data on a diet that's all meat. That is a raw, if you're eating a diet of nothing but raw meat, but I suspect some of the consequences would be very similar. And I suspect Neanderthals would not have lasted 200,000 or 300,000 years. They might have lasted 2 or 3 centuries and disappeared. So, but this is just one of these problems with cooking. I'm not arguing, therefore, they must have had cooking. We honestly, in my opinion, still don't know. The verdict is out. So what I want to begin talking about is how do northern foragers of the historic period, ethnographic and sort of the recent past, how do they prepare meat? And there are a number of different techniques. One that's very common, as I've already mentioned, is raw, and it's usually frozen. But as I mentioned, it's not something you just take out of the freezer and break your teeth on. It's very, very helpful in that it requires no fuel to prepare it. You don't need fire. And something that I'll be talking quite a bit about, it preserves vitamin C. This becomes, I think, really critical for people that are surviving on a high meat diet like traditional Eskimos did or do. Drying is not very common. It was certainly done. But the problem is in environments where it's damp or rainy and overcast, it's very hard to dry meat. And not only is it hard to dry it and keep it dry, but often you have to assist it with a fire. You have to use heat, and therefore you need fuel. And the drying leads to rancidity in the fats. Some of the products of rancidity can be toxic. So you need the fat, but if you have the LCPUFA or the long-chain polyunsaturated fats, the so-called good fats, they're very unstable and can oxidize. And also, drying leads to the destruction of vitamin C. Vitamin C is the most unstable of the vitamins, and on a high meat diet, it is absolutely critical to survival. Boiling is another common technique, but northern latitude boiling is not what you'd think of. First of all, it's done incredibly briefly, only a matter of a few minutes. You almost never see bubbles or a rolling boil. And Euro-American explorers were kind of disgusted by traditional northern latitude boiling. They didn't consider it cooking at all, but it was always referred to as boiling. Could Neanderthals have boiled? I'm going to just touch on this very briefly. Archaeologists were the last people to get the news. We have assumed that you can't boil in a perishable container. Everybody else knew that you can. Boy Scouts, Girl Scouts boil in paper cups, in paper bags. You can boil in leaves. You can boil in plastic. You can boil in anything you want, placing it directly on the fire, and it will not burn. I learned about it because my son watched a TV program called Survivor Man, and he would boil water in a plastic water bottle. Put it directly in the fire. If you know the book Clan of the Cave Bear by Jane Owl, published in 1980, she learned about it not from archaeologists, even though there are a lot of Neanderthals in that book. She learned about it from wilderness survivalists. The earliest mention I found out about it was Herodotus in the 5th century BC, who talks about boiling oxen meat in the hide of the oxen that you've killed and then using the bones for fuel. So you basically let the ox cook itself, and no heated stones. And here's one of my favorite books, 50 Dangerous Things You Should Let Your Children Do. And experiment 13 is to boil water in a paper cup on the stove. Now, why archaeologists have always assumed that you have to use heated stones in a perishable container. As I say, we are the last to find out about it. Herodotus knew about it in the 5th century BC. You can boil in leaves, and this doesn't prove that Neanderthals boiled, but it's certainly, you don't have to be a rocket scientist to figure it out. So I think it's very likely. Given that we know that Neanderthals were making birch tar, they may well have been boiling in birch baskets, birch containers. They're used ethnohistorically all over the place. You place them directly in the coals, and so long as there's liquid in it, they won't burn. So the fifth technique used in the Arctic and subarctic is to rot your meat. And this is what I'm going to focus on. It's a nice stinky topic. I want to read you one quote in case you can't really see it in the back. This is one out of hundreds that one can pull out of the literature, and I'm glad we aren't at lunch yet. We came upon the Eskimo carrying an immense seal, which had been buried at least 2 years. Maggots dropped from it at every step, and the odor was terrible. Mr. Peary told him that it was out of the question to put that thing in the boat. The Eskimo was angry at being obliged to leave his treasure. He told us that the more decayed the seal, the finer the eating, and he couldn't understand why we should object. Going through the ethnohistoric literature, the earliest one I've found so far is a very vivid description from 1577, and this tradition of eating rotted meat, some meat being let to rot for as much as 2 to 3 years, continues today in many parts of the Arctic. Interestingly enough, no evidence of botulism until the 1970s, when Euro-Americans decided that it was unsanitary and introduced sterile glass bottles and other techniques for accomplishing it, and that's when botulism begins to appear. I frankly don't understand why, and if there are microbiologists in the audience, I would love to learn more about this, but botulism was not a major issue. So, limiting factors in the Arctic. Let's look at these. I mean, there are other ones that I'm not talking about here, like fat, which I think is an absolutely critical one. But one is scarce fuel. And obviously, not all areas of the Arctic and subarctic had a fuel shortage, but many areas where you don't have wood, fuel can be a real limiting factor, and obviously that is a severe limitation on how much cooking you can do. A damp, overcast climate, as I mentioned, can be a real handicap to drying, and both cooking and drying can lead to the loss of vitamin C, and in an area where you're relying heavily on meat for your diet. And Eskimos, traditionally, their diet was more than 90% meat, and sometimes approaching 100% meat. Vitamin C becomes really, really critical, and it can certainly be critical seasonally during the winter, even if you have fruits and vegetables at other times of year. The absence of vitamin C or scarcity leads to scurvy. I put it, the French word, if you're not familiar with it, le scorbut. And to give you some idea, there is virtually no vitamin C in muscle. And so muscle meat, which is what Euro-Americans particularly like, is devoid of vitamin C. Interestingly, and perhaps counterintuitively, at least in ruminants like reindeer, there is no vitamin C in the stomachs, even though Eskimos and others relish eating the stomach contents. It's a major source of carbohydrates, but not of vitamin C. It's found in the organs, the brain, the liver, the testicles, the eyes, and many of the other organs. It's the most unstable vitamin. It oxidizes very rapidly and can be lost by both cooking and drying. So, and if you're subsisting on a largely meat diet, this can become a really critical problem. It's most stable in an anaerobic environment, that is an environment without oxygen, and in very acid conditions, pH less than about 2. And that is the ideal environment that's produced by putrefaction, rotting meat, or what you might call fermentation. When you get a pH below 2, vitamin C becomes stable. Ruminant stomach, the reason there's no vitamin C in a ruminant stomach is the pH typically is around 6. And there's a good chance that there would be vitamin C in the chyme or the stomach of a monogastric, let's say like an equid, a horse, a zebra, and so forth. And that could be one reason that makes equids in the Paleolithic attractive. I'm sure that's not the only reason they'd be out hunting them, but that's one possible factor. but reindeer would not produce vitamin C except in the organs. Now, the history of scurvy, it's estimated that at least 2 million sailors in Europe died just in the 3 centuries between AD 1500 and 1800 that has died of scurvy, of le scorbut. In the 18th century, they figured out that you could prevent scurvy or cure it with fresh lemon juice or lime juice. The problem is, to make it satisfactory for use on ships, they boiled it in copper vessels, and that destroyed the vitamin C, so it didn't work. There were a number of attempts at solutions, and one of the most effective was Captain James Cook in his Pacific voyages in the late 1700s, and what he used was sauerkraut. In other words, putrid cabbage. All right, rotted or fermented cabbage. And under those conditions, low pH and anaerobic conditions, the vitamin C lasted for more than 2 years. And he had no problems with scurvy. So problems with it, European explorers and American explorers, they wanted, many of them died of scurvy. The natives did not. The explorers wanted muscle meat. They liked steaks, and they roasted them. And that first of all, there's no vitamin C in the mussels anyways, and roasting would destroy any vitamin C that might have been present. And they were generally disgusted by putrefied meats. Putrefied organs, putrefied muscle meat, it didn't matter. That was disgusting. Maggots were disgusting. The Arctic hunter-gatherers loved to rot the meat. They loved the maggots, and that's the way they ate a lot of their food. They often froze it, but it was frozen rotten. And it might have been stored for months, weeks, months, even years. So you don't need much vitamin C, but it's not going to last if you roast it, and it lasts best if you rot it. What does it do? It does exactly what cooking does in many ways. It pre-digests the food, but without the need for any fire or fuel. It blocks pathogens. It inhibits rancidity of the fats. It preserves the vitamin C. It's very easy to store. It's low-tech, fairly simple technology. One of the most effective ways is to simply weight it down in the bottom of a pond. And it ends up tasting like cheese, but it can last for well over a year, right through summer, and be non-hazardous, no botulism or anything else. And as possible examples, although a lot of people would disagree with this, I think Schoeningen might be a classic case of pond storage. In that case, horses, and an upper Paleolithic site of Stelmoor, where you have reindeer with actual rocks in their chest cavities that were apparently, I think, were weighted down. They were probably being nicely rotted at the bottom of the lake or river or whatever it was. My conclusion on that is, I think for these kinds of diets, a heavily meat-based diet in a subarctic environment, at least seasonally, you would have to rot some of your meat in order to avoid scurvy. So how does this relate to isotopes? First of all, it's very misleading to talk about Neanderthals as hypercarnivores. They are not hypercarnivores, they're primates. A hypercarnivore can thrive on a diet that's 70% protein. A human will die in 3 or 4 weeks on a diet like that. A human's upper threshold is about 250 to 300 grams of protein per day, which would translate typically into, let's say, 35% of calories, half of what a hypercarnivore can eat. So you can eat a 100% meat diet, but most of it has to come either from fat or carbohydrates. Let's say if it's all meat, it has to be mostly fat. And one of the major unresolved questions, as far as I'm concerned, is where did Neanderthals get all that fat, especially if they didn't have fire and couldn't boil. They couldn't render the grease out of bones. So here's a typical northern latitude diet: 25 to 35% protein, or the lean part of meat, 65 to 75% fat, almost no carbohydrates, How would a Neanderthal get that kind of diet? To me, this is one of the million-dollar questions we have yet to resolve. So, as I said, the hypercarnivore is perfectly happy at 70% protein, and Neanderthals, I think, would have dropped dead rather quickly. You can eat crushed bone, but how much? First of all, and there's an archaeologist named Eugène Morin, who is actually getting data on how long it takes you to crush bone to the point where you can actually swallow it. And then what happens to your intestinal tract? How much bone do you have to swallow to get enough grease to provide this 60 or 70% fat? I'm not sure it's a viable solution. I think you'd end up looking like a solid bone. And an alternative, of course, is plant foods, stomach contents, whatever, seaweed if you're near the coast. And as has been talked about already, there is increasing evidence now of reliance on plants, and this lists some of the obvious ways that we're beginning to discover how important plants might have been in Neanderthal diet. Flotation, producing macro remains of charred plants, phytoliths and starch grains, and DNA and dental calculus, residues on stone tools, and then other more hypothetical things like eating stomach contents. It's highly likely, we don't have any direct proof of it yet, but I think it's extremely likely. Eating the inner bark on certain trees would be another major source of carbohydrates. Again, people have hinted at it. How we're going to demonstrate it is something else. Does putrefaction affect the nitrogen isotope content or ratios? And I think the answer is yes. There are 4 experiments, at least that I'm aware of, that are already happening that are showing that yes, meat is enriched by putrefaction or rotting. One of the major gases produced when you rot meat is ammonia. In other words, rotten meat often smells like pee. And you get a loss of the light isotope in the gas, and you end up with enriched meat. The larvae under the hides are a major delicacy in the Arctic, and they're operating as carnivores. They're eating the reindeer. And so if you then eat these larvae, the fly larvae, you're getting enriched nitrogen. We have no data on the nutritional content of these larvae. Nobody's looked at it, nor how many were part of the diet. And then the maggots in meat. And when you look at the ethnohistory, they were considered a delicacy. Some of the Europeans were told, well, just think of it as eating rice soup. And that didn't seem to work. But at any rate, the maggots, again, nobody's done an actual study of them to my knowledge, but I suspect they are also heavily enriched in the heavy isotope. So in terms of conclusions, I think in Arctic and subarctic environments, the more heavily meat-based your diet, whether it be on a year-round basis or just seasonally, let's say overwintering, if you want to avoid scurvy, you have to rot some of your meat in order to get enough vitamin C. You may need it to conserve fuel. Since in many ways putrefaction does what cooking does, but without the need for fire, it greatly decreases the metabolic costs of ingesting and assimilating the meat. This doesn't explain the absence of fire totally, but it could certainly contribute to an underemphasis on fire in Middle Paleolithic sites. And I think I'll stop there. Thank you very much.